All right, this is a video continuing section 2.4, but focusing on the difference quotient, or the quotient rule, I should say. So the quotient rule is when you have a function that you're trying to take the derivative of, and you have a polynomial or a function on top and another function on the bottom. So the rule here, and this is kind of the generic formula for that, is that we do the derivative of the first times the second again. This time we do minus, though, the first times the derivative of the second, and then all over the second squared. And that's just the original function, not the derivative of the second. The big kicker here is that for this formula to work, g of x cannot equal 0, because then you'd be dividing by 0. So we're going to use this formula to help us do a few more examples that we didn't get to in class. So starting with number 2. So I'm going to let f of x be my top function, and g of x is going to be my bottom function. Then I'm going to start my work over here. So f of x is going to be our first function. It is 5x squared minus 2. The derivative of that, we pull the 2 to the front, multiply it by the 5, that would be 10. Then we lose a power, and then you can't take the derivative of the constant, that would just be 0. The second function, you have x plus 4, and the derivative of that would just be 1. Anytime you have just x to the first power, the derivative is always the coefficient in front of it. So this one's not too bad. So let's write out our formula for y prime. So y prime is, remember, the derivative of the first one. So that's 10x times the second function. So that's x plus 4. Minus, that is a key difference here from the actual product rule. And then it's the first function, which is 5x squared minus 2. Times the derivative of the second, which is just 1. And then that's all over the second function squared, so x plus 4 squared. Okay, so we're going to work out what we can for this. So on the top, we would need to do all of our distributing and working out like terms. So 10x times x is 10x squared. 10x times 4 would be 40x. Be careful here, this is a negative 1 that we're really distributing if you want to think about moving that to the front. This is going to be negative 5x squared and positive 2, because it's negative times negative, all over x plus 4 squared. If we continue with the simplifying on top, that's going to be 5x squared plus 40x plus 2, all over x plus 4 squared. Now, we haven't done a lot of these where you've had to simplify anything, but it is a good thing to check. If you have 5x squared plus 40x plus 2, you would do 5 times 2, which is 10, to try to factor this by grouping. The factors of 10 are 1 and 10 and 2 and 5. There's no way that that's going to make 40, so this does not factor. You always want to double check that, though, because if it factored and it had an x plus 4 as part of its numerator, that would cancel with one of the x plus 4s on top. So it's always important and a good idea to check that. So that is our derivative of that function, that quotient. Okay, let's look at another one. So we didn't do 3 together. So for number 3, I'm going to let f of x, well, they've already called it f of x, so we're going to call the top h of x, and the bottom is going to be g of x. So my first is that h of x equals 2x squared minus 4x plus 7. The prime of that would be 4x minus 4. For the second function, g of x is 6x minus 1. G prime of x is just 6. So f prime of x is the derivative of the first, which is 4x minus 4, times the second function, which is 6x minus 1, subtract the first function, which is 2x squared minus 4x plus 7, times the derivative of the second, which is 6, all over the second function squared, not its derivative squared. So 6x minus 1 squared. Okay, so we're going to work out the top here. So we're going to FOIL over here this first group. So that would be 24x squared minus 4x minus 24x plus 4. Be careful here. I actually like to rewrite this as negative 6 times all of that. so that you realize that not only are you distributing a 6, but you're also distributing the subtraction sign. So this would be negative 12x squared plus 24x minus 42 all over the 6x minus 1 squared. Adding like terms on top, we're going to get that f prime of x is 12x squared. This would be negative 28 plus 24, so that's going to be negative 4x. And then 4 take away 42, we're going to get negative 38 for that, all over the 6x minus 1 squared. So let me just double check my math there. So 24 minus 12 is 12. That's negative 28 plus positive 24, so that's negative 4x, and then a positive 4 and a negative 42. Okay, so we've got that top part correct. Now before I circle it, I am going to double check. 12x squared minus 4x minus 38. 38, not 36. If we're going to try to factor that, we would do 12 times 38, which is 456, which is going to have a lot of factors, 1 and 456. 2 goes into it 228 times. Does 3 go into it? So this is just reminding you how to check for factoring. Yep, 152 times. 456 divided by 4 is 114. 5 does not divide into it evenly, but 6 probably will. 76. See, they're getting closer and closer together. So let's see if 7 goes into it. Nope. Does 8 go into it? 8 and 57. Does 9 divide into it? Nope. 10 does not. Does 11? Nope. Does 12? Yes, 12 and 38. We should have known that. That's how we multiplied it. Let's see, does 13 divide into it evenly? No. Does 14? No. 15 shouldn't. 16 does not. 17 does not. 18 does not. And notice the gap is getting closer. I plugged in 18 for dividing and I got a 25.3. Does 19? No. Oh, yes, it does. 19 and 24. And let's keep going just a little bit further because those are close together. 20 doesn't go. 21 doesn't go. And I'm pretty sure we're at the end of our list because notice this is a 21.7. If you move up 1, 456 divided by 22, the part you've divided by is now bigger than the part you got as your answer. So that means you've passed the point where all the factors have now been listed. And notice that this is a negative 456. If we multiply the 12 times a negative 38, the only way we could get negative 4 is by subtracting, and these two are not going to give us negative 4. So that means it doesn't factor. But it's always good to get in the habit of checking those because you never know if it factors into a 6x minus 1. And usually you could play around with trial and error and figure that out a little quicker. This one had a large factor. Okay, let's look at number 5. So for number 5, whoops. Okay, there it goes. So number 5, we're going to let f of x be the top function since this is just called y. And g of x is going to be the bottom function. So my first guy is f of x, which is just x squared, which means its derivative is 2x. The second one is going to be g of x, which is x minus 8, and its derivative is just 1. So using our formula, y prime is equal to derivative of the first times the second function minus the first function times the derivative of the second, all over the first function squared. Or excuse me, second function squared. I'm writing it correctly but saying it incorrectly. This one's always second function squared. So if we work this out on top, this is 2x squared minus 16x minus x squared over the x minus 8 squared. That's going to be x squared minus 16x over x minus 8 squared. And notice that this one does have something that factors out of the top. If you pull an x out of the top, you get x minus 16. You can't use perfect squares because this is an x to the first. So this would be another acceptable form of that answer, but it doesn't cause anything to cancel. So usually if it doesn't help, we go with it before it was factored. So just as an FYI there. All right, and then the next one we're going to look at is number 6. Now this one has an extra piece of information at the end. At the very end of this, it says f of x at this point. So there's some directions missing here. I'm going to write them in. This was how it would read on the homework on WebAssign. It says find the value of f prime of x at the point provided. Okay, so there'd be directions here to tell you that this point is going to get plugged in to the function after we're done. So let's find the derivative first. So f of x is going to be 3x. Oh, we're going to call it h of x. Yeah, always be careful. If this is an f, I try not to use that again. It gets confusing. So this will be 3x. H prime of x would just be 3. The bottom is going to be x squared plus 6. And then its prime would be just 2x. So for the derivative of f prime of x, we're going to have derivative of the first times the second function. So once you've done this enough, you really just memorize the formula. There's not much else going on. And then the first function times the derivative of the second, all over the second function squared. Okay, so this will be distributed this out, and this gives me 3x squared plus 18 minus 6x squared all over x squared plus 6 squared. And then I'm going to combine like terms on top and get that's negative 3x squared plus 18 over x squared plus 6 squared. Now on this one, can we actually reduce? Let's see. Well, if we pull a negative 3 on the top out, that's going to give me an x squared minus a 6. So it's very close, but it's not a match. So because of the sign, that doesn't actually help us with canceling. But it is important to note that I checked it because you never know. If that had been a plus, then we could have reduced an x squared plus 6 with an x squared plus 6. So we don't actually need this version if it doesn't help. Now they did ask us to evaluate this at -1 because remember when we evaluate we use the x value because it's f prime of x. So f prime of x, which x is now going to be -1. We plug in -1 to our derivative, so negative 3 times -1 squared plus 18 over -1 squared plus 6 all squared. -1 squared is 1, so that's going to be -3 plus 18 on top. -1 squared is 1 plus 6 will be 7, so that's going to be 7 squared on the bottom. I am getting 15 over 49 as my evaluation. So there's that. Okay, so we did number 7, I believe, in class, which was finding the equation of the tangent line. So let's look at number 8, which is also finding another equation of a tangent line. Okay, so if we find the equation of the tangent line, we first need to find the derivative. So we need this. So my top's going to be h of x. My bottom's going to be g of x because this is a quotient. We're going to use the quotient rule. So h of x is x squared minus 4. H prime of x is 2x. G of x is 2x plus 5. And g prime of x is just going to be 2. Okay, so using our formula for f prime of x, we take the derivative of the first, which is 2x, times that by the original second function, which is 2x plus 5, minus, then we have the first function, which is x squared minus 4, times the derivative of the second one, which is 2, all over the first function squared. Okay, so we distribute this. This is going to be 4x squared plus 10x. This will be a negative 2 times all of this if you want to rewrite it. So that's going to be negative 2x squared and plus 8 all over 2x plus 5 squared. Combining like terms, we get that that is 2x squared plus 10x plus 8 all over 2x plus 5 squared. Since I'm not actually going to be doing any simplifying, I'm not even going to check for factoring here. All I want to know is what is going to be going on with this slope of the tangent. So I need to plug in the 0. So if we plug in 0 for our derivative, that would give me 2 times 0 squared plus 10 times 0 plus 8 over 2 times 0 plus 5 all squared. The top is just going to be 8. The bottom is going to be 5 squared because 2 times 0 is 0, but then you have to add 5 to it. So that's going to be 25. So that's my slope of my tangent. Now, they only gave me x equals 0. Remember, if I want the other part of my point, we plug in the 0 into the original function. So that's going to be 0 squared minus 4 over 2 times 0 plus 5. That's negative 4/5. So the original point we are talking about is 0, negative 4/5. So once you have your point and your slope, so remember this is a point on the original equation, we can find the slope of that tangent line. We've got that. We've got the point that it's going to touch. We can now find the equation. So y minus the y value of the point equals the slope times x minus the x value of the point. That's just going to be y plus 4/5 equals 8/25 x. 8 times 0 is just going to be 0, so that guy's going to be gone. And we just need to subtract over the 4/5. So this is 8 over 25x minus 4/5. So there's the equation of the tangent line. And then the last one in section 2.4, and that'll get us caught up completely with all possible examples that were in sections 2.3 and 2.4, is this number 9. Again, they're asking us to find a symbolic representation of this because they're saying find f prime of 2 when your equation is just, hey, it's a function of 2 different functions stacked. So we need to write this symbolically what the derivative is. So that's, remember, our formula. So f prime of x is, remember, the derivative of the first, which is always the top one, times the second function, which is always the bottom one, minus the first function times the derivative of the second one, all over the second function squared. So do we have everything we need? We have g of 2, we have g prime of 2, we have h of 2, we have h prime of 2. It looks like we have everything we need. So g prime, so if we're going to do this for f prime of 2, so let's just write that down here. G prime of 2 would be negative 2 times h of 2 would be negative 1 minus g of 2 is 3, h prime of 2 is 4, all over g, oops, I wrote that backwards. Sorry, fix my notation. The second function is the bottom one, so sorry, h of x squared. So h is going to be negative 1 squared. Okay, so we're just working out order of operations. So yeah, remember this is always first, this is second. It's easier if you label them like that so that you can put them in the right places here, because it is very easy to make a mistake, and it's always easy to do when you're talking through it. So negative 2 times negative 1 is 2. That would be minus 12 over negative 1 squared is 1. So this is just going to be negative 10. Now that is f of f prime of 2. So symbolically, we didn't have to do any algebra here except plugging in the numbers after we located where they belonged. So it's really not a bad problem, but I find that these are ones that students miss a lot just because it's that setting up the symbolic formula for this, because once you do that, you're just plugging in the y values of each of these. So that's it for 2.4, and we will start our lesson tomorrow at 2.5, the chain rule.